So I put together a new Raspberry Pi case, and this one's got a camera on the front of it, and it is on a pan tilt servo mechanism. So I've got a little breadboard because I'm using an external 5-volt power supply. I'm using my benchtop power supply because it needs 5 volts, which is too much to draw just from the Pi, so it needs its own power. This camera is pretty cool. It's a wide angle, and it has night vision that comes on automatically. You can see the little light resistors there. So I've scripted up a pan tilt mechanism using Python, and then I've got a web server running on it. The idea is this is going to run from battery, and it's going to be on a tank tread robot, so I can drive it around. But this is the camera here, and you can see that it's streaming the web page. It's upside down. I need to fix that, but check it out. So if we click pan and tilt, it pans and tilts. This is very, very rough, but it works well. At least I've got it prototyped and tested, and now I can start refining it, making finer adjustments, getting the image right side up. Oh, and of course, setting up the PWM motor control. So for that, I've got this little bad boy here. This takes a single GPIO pin, uses the IC2 protocol, and it basically gives you 16 servos off of one pin, which is excellent because you couldn't get 16 servos off the 40 pins of the GPIO. And you can stack these for more servos. If I wanted to add an arm or something and I ran out of servos. But 16, I'll need 2 for the pan and tilt, and I'm going to need 2 for the tracks. So that's just 4. I can have PWM for stuff like turning on other infrared lights, turning on or off sensors. I might put a laser pointer on it to play with the cats. So this is the servo controller board. For power supply, I've got this little DC-DC, got a word for this, kick block, something like that. But this is a DC-DC power supply, so anything from 12 volts to 36 volts come in, you program it, and you can get 5 volts, 12 volts, 24 volts, whatever out of it. And it's a switched power supply, so it will maintain that voltage even as the battery voltage changes. As the battery starts getting down and starts getting low, the voltage isn't going to dip or drag or whatever. So this is going to be very useful because I can use a radio control car battery to run my Pi and get 5 volts for the Pi, and get 5 volts for the servo. But I can use a big honking, 6-cell or whatever RC battery. And just to give you an idea what that's like, I've got some small helicopter batteries over here. I can get back there. Oh, there we go. So, so this is a modest 6-cell helicopter battery. For one of those bad boys up there. It weighs about a kilo, so about 2.5 pounds. This thing is 6-cell, so it's 22 volts. It's 6,000 milliamp. So it's like a car battery. So this guy running a very efficient tracked robot, I'm going to be able to get several hours of runtime out of it. Let me show you the chassis that I'm going to build this on. So it uses tracks, and the chassis itself is pretty small. I mean, it'll fit the Pi no problem. So you've got little motors that run the tracks. They sit in like that, and basically it'll look like this. It has a suspension, so it can go over bumps. It can handle changes in the height of the terrain. And then the Pi is just going to sit right on top. I mean, it's a perfect fit. And this little guy can get in under the bed, get to hard to reach places. Find out where the cat's hiding under the couch, stuff like that. And it'll all be served up over Wi-Fi. I'm sure I can use Bluetooth for controlling it, kind of like an RC car. But what I would like to do is be able to control everything through a web interface, and set it up to do, line following or something like that, and have it patrol the house as a security bot. So that'll be fun. Anyway, that's kind of what I've been doing this afternoon. Take it easy.